Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 1 to 5 of the August 2019 Algebra 2 New York Regents test. Notice this is a detailed consideration of the problems. If you like a real quick view of the solutions, you can visit our website at mathgotserved.com. Alrighty, let's take a look at question number 1. In question 1, we're going to be learning about how to factor and distribute polynomial expressions. We're going to be looking at quadratics in this example. So in problem 1, it reads, when the expression quantity x plus 2 squared plus 4 times the quantity x plus 2 plus 3 is rewritten as the product of two binomials, the result is, and we have 4 options here. All right, so we're going to solve this problem using 2 methods. Okay, we're going to use the first method, method 1. We're going to call that the U substitution method. Okay, method 1, U sub. All right, let's take a look at how to solve this problem using the U substitution method. So we have this quadratic right here, x plus 2 quantity squared plus 4. Now what you notice is that the quantities in the parentheses are identical, x plus 2, x plus 2. So if we substitute them out with another letter, it results in a quadratic that's in a simplified state. Okay, so let's make a substitution here. Let's say u be x plus 2. Okay, if we make that substitution, now we'll take out the x plus 2's and it'll now become u squared plus 4u plus 3. Now, which one is easier to factor, this original quadratic or this one right here? Clearly, the one in the u format is easier to factor. All right, so that's the beauty of the u substitution. It enables you to rewrite the complex problem in a simpler state, which is easier to factor. Okay, so we're going to factor this quadratic trinomial using the AC method or the X game. So in this situation here, AC is 3, because you note that, let's put the side information. In this particular quadratic trinomial we have right here, A is 1, the coefficient of the second degree term, B is 4, and C is 3. We know that. All right, so A times C goes on the top and then B goes on the bottom. B is 4, and then we play the X game. What two numbers multiply to give you 3 and add to give you 4? The answer is 1 and 3. Okay, now in this particular factorization problem, you notice that A is 1. What does that mean? Well, since A is equal to 1, you skip grouping. You don't need to factor by grouping when you have a situation where A is equal to 1. You jump right to the factored state. So it's going to become u plus, you take the first factor, positive 1, times u, and then the second factor plus 3. So that's the factorization of this u right here. Okay. Now, if we take a look at what we have, it's in terms of u. But the options that we have are in terms of x. So in order for us to finish this problem, we have to resubstitute. We'll have to resubstitute our u's with the original x values and then simplify the resulting expression. Okay, let's go ahead and do that. What are we doing? We're going to resub u with its original value, x plus 2. Okay, so if we carry out the resubstitution, we're going to have, instead of u plus 1, it will be quantity x plus 2 plus 1 for the first factor upon resubstitution, and then the second factor, instead of u plus 3, it will be quantity x plus 2 plus 3. Okay, now let's go ahead and substitute the individual quantities in the parentheses right here. So here we're going to have x plus 2 plus 1, and then over here we have x plus 2 plus 3. If we simplify further, combine like terms, here we have x plus 3 times quantity x plus 5. Ladies and gentlemen, that's the answer to question number 1. Our answer is option letter 2. We know that multiplication commutes. The order of the product of factors does not really matter. Alrighty, okay. So this is method 1 using the use substitution method. Now let's take a look at method 2, and then we'd like to know which method you prefer. Okay, so for method 2, this is basically is not that sophisticated. Method 2, in this case, we're going to expand and factor. All right, we break it down completely by expansion, and then we just factor the resulting simplified expanded expression. Alrighty, let's do it. So we are starting with the original problem is quantity x plus 2 square plus 4 times quantity x plus 2 plus 3. Now let's expand this completely, okay? So we have quantity x plus 2 square, which means that we're going to multiply x plus 2 by itself. And then 4 times quantity x plus 2 means positive 4 will be distributed to x and then 2. If we carry out that distribution, we have plus 4x plus 8 plus 3. And then this right here, we're just going to FOIL it out, okay? Double distribution first, outer, inner, last. So when we do our first and outer, we are going to have x squared plus 2x. And then we proceed to do our inner and then last. Okay, that will give us plus 2x plus 2 times 2, 4. Plus 4x plus 8 plus 3, we can add those two together. 8 plus 3 is 11. Alrighty. Now let's simplify further. Like terms can be combined. We have x squared, the second degree term. There is only one of that, so we just bring it down, x squared. First degree terms, we have, what do we have? 2x is the first degree term, 2x and 4x. If we combine all those together, 2 plus 2 plus 4, that is 8 plus 8x. Okay, and then our constants, we have positive 4 and 11. Combine those two, 4 plus 11 is 15. Okay, so this is the expanded form. Now what we're going to do next is we are now going to factor. Okay, so first thing we did is we expanded completely, which is the first part, and now we're going to proceed to factor the expanded form, which is the second part. We're going to make use of the x game again as we did in method 1, but our values here will be slightly different. So in this particular problem that we have here, a is 1, the coefficient of a is 1 because there's a 1 here. B is what? B is 8. And then C is 15. AC goes on the top. AC in this problem is 15. 1 times 15 is 15. And then B is 8 that goes on the bottom. Now, ladies and gentlemen, let's go ahead and play the X game. What two numbers multiply to give you 15 and add to give you 8? Think about the factors of 15. This is just, what are they? If you make your T-chart, 1 times 15 and 3 times 15. Nope, 3 times 5. We have a complete loop right here. No other pairs of integers multiply to give you 15. So which one works here? We can clearly see that 3 and 5, 3 times 5 is what we desire. Why is that? Well, let's see. 3 times 5 is 15, and 3 plus 5 is 8. Now, since we have a situation where a is equal to 1, what does that enable us to do? Do you remember? Since a is equal to 1, we can skip grouping. You can group if you want, but it's a waste of time. So you gotta skip grouping here and jump directly to the factored state. So it just employs writing it as x plus 3, the first factor, and then x plus 5, the second factor. All right? So since there was no substitution done in this method, no resubstitution is required. So upon factorization, we will arrive at the factored state x plus 3 times x plus 5. Answer clearly is option number 2. All right, ladies and gentlemen, which method do you prefer? Method 1 or 2? Let us know the method you prefer in the comment section below and why, or if there is another method that you were able to devise that is even better than these two methods that we considered here. Alrighty, let's take a look at question number 2. In question 2, we're going to be learning how to find the sum of a geometric sequence, also known as a geometric series. Alright, question 2 reads, the first term of a geometric sequence is 8, and the fourth term is 216. What is the sum of the first 12 terms of the corresponding series? Alright, so let's go ahead and get started. We're looking for the sum of a geometric sequence, alright, or a geometric series. So let's write down the formula that's going to guide our problem solving process. So the formula for a geometric series, or the sum of a geometric sequence, is given by S sum of n terms equals a1, the first term, minus a1, the first term, times r raised to the nth power, the number of terms, divided by 1 minus r, where r is not equal to 1. All right, so let's write down what we need and what we know, and then find the sum. Okay, remember, if you have one equation, you can have only one unknown. All right, so what is a1? a1 is the first term. Okay, so a sub 1, the index tells you the position. It told you that the first term is 8, so a1 is equal to 8. We're asked to find the sum of the first 12 terms. Okay, so that's what we're looking for the sum for. So n is going to be 12, and then we have what we're looking for, the sum of the first 12 terms. S of n is going to be S of 12. That's what we're looking for. So we have a1, check. We have n, check. This is what we're looking for, okay? But what else do we need, ladies and gentlemen? You notice that the sum also depends on the common ratio r. What is the common ratio in this problem? The answer is it's not given. Ladies and gentlemen, do you see that we have a problem? We have only one equation with two unknowns. So we have infinite number of solutions. That's not going to work here. So in order for us to get one answer, we need to find a common ratio. How do we find a common ratio? Well, we have a clue. The fourth term is 216. Now that is the giveaway. That is what we're going to use to find the common ratio. Okay? All right, so we have a scenario where we have a problem within a problem. So we have to take a detour. What is the problem that's within this problem? Well, we need to find the common ratio r using a1 and a4. Okay? Find r using a1, a4, and the nth term formula. All right? So the formula that we're going to be using is the nth term formula. And so let me just specify the name of the formula so we don't get it confused. The nth term formula is an is equal to a1 times r raised to the n minus 1. So in this particular situation that we have right here, a1 is always is unchanging, that's 8. But for this particular problem, n is going to be 4. Okay? And then an represents the fourth term, which is what is it, 216. And then we're looking for r. All right, so when we're done with this, we should have all the information we need to find the sum. So let's set it up. So if we set it up, we're going to have an, which is, let me write down the formula again so that nobody gets confused with what's going on. All right, so an is a4, which is 216. So 216 is equal to the first term, 8 times r. R is what we're looking for. Raised to the n, which is 4 minus 1. Okay, so let's solve this resulting exponential equation for r. So to get r isolated, we notice we're multiplying by 8 here. That needs to go. So we can divide both sides by 8. When we divide both sides by 8, that's going to give us, what is that going to give us? 216 divided by 8. 8 goes into 21 2 times. And then 56 7 times. So 27 is equal to r to the 4 minus 1 is 3. And then to get rid of this power, we use the inverse, which is a cube root, is the inverse of a cube, right? So you take the cube root of both sides, and you're going to have r is equal to 3, because 3 raised to the third power is 27. Okay, now we have r. Perfect. So now we can find the sum. Okay. All right, so now find the sum. Now we can find the sum. Why? Because we have all the ingredients that we need. All right, so I'm going to rewrite the formula again, just to make sure none of us get lost with this. So S of n is equal to a1 minus a1r to the n divided by 1 minus r. So S of n is the sum of the first 12 terms, is equal to a1. a1 is 8 minus a1 again, 8 times the common ratio, which is 3 raised to the 12th power, divided by 1 minus 3. All right, so you can basically use your calculator to do this calculation right here. Just to make your life easier, you can simplify the denominator to 1 minus 3, which is just negative 2. Okay, and then when you plug this in the calculator, if you plug it in correctly, you should get 2,125,760. The answer to question number 2 is option letter number 3. Okay, so this is basically how you find the sum of a geometric sequence, or find a geometric series where r has to be found using the nth term formula. All right, so for our Algebra 2 students, we'd like you to rank the level of difficulty that you can assign to this problem. Let's say 1 is extremely easy and 10 is extremely difficult. What level of difficulty will you assign to this problem on a scale from 1 to 10? Easy to really hard, and tell us why you assign it that level of complexity. Alrighty, let's take a look at question 3. In question 3, we're going to be learning how to identify and classify functions based on an input and output table. Question 3 reads, Perry invested in property that costs him $1,500. 5 years later, it was worth $3,000. And 10 years from his original purchase, it was worth $6,000. Assuming the growth rate remains the same, which type of function could he create to find the value of his investment 30 years from his original purchase? So we're going to use an exponential function, linear function, quadratic, or trigonometric function. So in order to help us to pick the correct function, we're just going to create an input and output table and study the behavior pattern of the outputs, considering the input, and then we should be able to determine the right function that's most appropriate for this scenario. Okay, so we have the starting amount, we have year 5 and year 10. So basically, we're not looking for year 30. We just want to figure out what function will best help us determine which one to use. Okay. All right. So x is the input, f of x is the output. So starting 0, we have 1500 at the start. Okay. And then after 5 years, it was worth 3000. And then after 10, it was worth 6,000. So the question here is this repeated addition or is it repeated multiplication? Let's see. If it's repeated addition, you add 1500 to this right here. That gives you 3000, check. If you add 1500 to this right here, that will give you 4500. That's a fail. Ladies and gentlemen, it is not repeated addition. Let's try repeated multiplication. 1500 times 2 gives you 3000. 3000 times 2 gives you 6000. Check, check. Ladies and gentlemen, this is a repeated multiplication. Repeated multiplication by a constant. All right, you multiply by the same number every single time. Okay, so what type of function grows by multiplying by a constant over and over and over again? Ladies and gentlemen, repeated multiplication can be expressed in a simplified form as an exponential function. Okay, exponent just means repeated multiplication. So repeated multiplication implies that you're dealing with an exponential function. Exponential function. So the answer is option number 1. Okay, so let's go ahead and write down some notes concerning how to identify these different functions. So for the first one, exponential function involves repeated multiplication. Repeated multiplication by a constant. Okay. And then for linear function, guess what that is? For linear function, that one involves repeated addition. So if you think about arithmetic sequences and geometric sequences, that highlights the difference. Okay. So for example, in problem number 2, I believe. Yeah, problem number 2, we had repeated multiplication. That was a geometric sequence scenario. Okay, so repeated multiplication, exponential functions. Think about geometric sequences. This is the same thing. Okay, and then repeated addition. Think about arithmetic sequences. Okay, so if you have a growth rate where you add the same constant every single time, that's linear. But when you're multiplying by a constant every single time, as is the case here, that's exponential. Alrighty, so for quadratic, that involves raising the inputs to a certain power. So it's input raised to the second power. Alright, so this one, you look at the input-output relationship. And then for number 4, trigonometric function, trig functions. For trig functions, what you want to look for is oscillation. Okay, oscillates. What does oscillation mean? Well, oscillation means that it basically goes up and down. So that's like a sine function. Okay, so a function that oscillates, it goes up and down. You think about the currents of the ocean, for example, that oscillates, or the movement of a pendulum back and forth, back and forth. That's a trigonometric function scenario. And then quadratic function, we have the input raised to a second power. Sometimes there could be a linear component there, but just a pure quadratic function is just the input raised to the second power. So this one could be y equals sine x. Okay, and then for linear function, y equals mx plus b. And then for exponential function, you can just have y equals a b raised to the x power. All right, so linear is just a straight line, and exponential function just increases at an increasing rate, kind of sort of like that. Alrighty, so this question is an exponential function scenario because we have a scenario where the function grows by repeated multiplication. Alrighty, let's take a look at question number 4. In question number 4, we're going to be making use of the factoring methods for sum and difference of cubes. Problem 4 reads, a to the third power plus 27 is equal to quantity a plus 3 times quantity a squared plus ma plus 9. Then m equals, so we want to find m. All right, so before we get started, let's go over the formula that will guide the problem solving process. All right, so the formula that we're looking for here are the sum and difference of cubes. So let's look at the sum first. Okay, so if you have a to the third plus b to the third, so you have the sum of two cubes, it factors into a plus b times a squared minus ab plus b squared. And then a to the third minus b to the third is equal to a minus b times a square plus ab plus b square. Okay, so hopefully you remember the SOAP acronym. All right, the SOAP acronym is how you easily remember the formulas. S is for same, O is for opposite, and then AP is always positive. What on earth is this? Well, this SOAP acronym helps you remember the behavior of the signs when you're factoring sum or difference of cubes. So you look at the first sign. So this one is positive, right? So in the factored state, you notice the first sign is the same as this. The second sign is the opposite, so plus, minus, and the last one is positive. For the minus case, this is minus, so you notice the first sign is the same, the second is opposite, and the last one is always positive. So it's just a nice little acronym to help you remember the formula. This is a cubed plus 27, so we're going to be using formula number 1. We are going to be using the sum formula to solve this problem. Okay, all right, so let's go ahead and set it up. All right, so let's write this down. I'm going to write down the formula on the top. Okay, so the formula is going to be a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So we're applying this formula to this scenario right here. A to the third plus 27. Okay. All right, so we can clearly see that a, in this particular problem, a is equal to, a cube is equal to a cube, right? So if you cube root both sides, a is a. And then we have b cubed is equal to 27. All right, so this one we took the cube root of both sides. So we have a is equal to a. Now, what is b? We take the cube root of both sides and we'll find out that b is equal to 3. All right, so b is 3. So if we substitute it here, we're going to have a plus 3 times a squared minus ab. So ab is 3a plus b squared plus 9. Okay. All right. Now what we're going to do is write down this formula, what we're asked to find. Let's put it underneath here. So we're given in this particular problem a plus 3, check, check. A square, check, minus plus ma plus 9. So we're looking for the value of m. So the middle term helps us to find the value of m. So what we're going to do is we're going to equate the middle term of the factored form with the middle term of the unknown component. Set them equal to each other and solve. Okay, so when we equate them to each other, we are going to get ma is equal to negative 3a. So to get m by itself, we're going to divide both sides by a. And our final answer, ladies and gentlemen, m is equal to negative 3. The answer to question number 4 is option number 2. Alrighty, so this is basically how you use the sum and difference of cubes formula to factor cubic binomials. Alrighty, ladies and gentlemen, let's take a look at question 5. In question 5, we're going to be learning how to find a trig function given another trig function. 5 reads, if cosine theta is equal to negative 3 over 4 and theta is in quadrant 3, then sine theta is equivalent to. So here we are given cosine and we are expected to find sine. We're going to use 2 methods to solve this problem. And at the end of this presentation, we'd like you to tell us which method do you prefer and why. Okay? All right, so method 1, we're going to be using the right triangle trig method. Okay? Right triangle trig method. Let's do it. So it just involves us here in this particular scenario drawing the triangle in standard position and then using SOHCAHTOA to finish it off. Alrighty. Okay, so let's go ahead and do that. Alright, so we're told that the theta is in quadrant 3, so that tells us exactly where our triangle is going to be located. Okay, so let's draw our triangle in standard position. So that goes our x-axis and our y-axis. So the angle in standard position basically means that you draw your angle to the closest x coordinate. It's always an acute angle, okay? So theta is in quadrant 3 in standard position means that theta is right here. Bam. Okay, so how are we going to label our triangle? Let's label it using this angle as a reference angle. Let me write my theta properly. Looks strange. Okay, so if this is the reference angle, that means this side right here, this side is the opposite. Okay, so that's the opposite. Let's call it OP. The side opposite the 90-degree angle is the longest side of a triangle. And the longest side of all right triangles are known as what? As your hypotenuse, right? Let's just call it H. And then the third side is the adjacent. So we have this ratio right here. We have cosine theta is equal to negative 3 over 4. So which is which? What is the opposite adjacent hypotenuse? Well, to help us figure it out, we're going to call up our nice little formula, SOHCAHTOA. All right. SOHCAHTOA tells us the relationship between the reference angle and 2 sides of the triangle. So we're looking at the C situation. C is ka, which tells us that the numerator is the adjacent, the denominator is the hypotenuse. Remember, the hypotenuse is always positive, so this automatically shows that A is negative 3. Alrighty, so let's go ahead and do that. So A in this problem is negative 3, and our hypotenuse is 4. Alright, now the problem asks us to find sine. So what we're going to do is we're going to use this right triangle that we have here, in quadrant 3 to figure out what sine theta is. All right, so how do we relate this angle and any pair of sides with sine? Well, that's what so helps us to do. All right, so we're going to use so. So what does so mean? So basically means that sine theta is equal to opposite OP over adjacent A. We know that our opposite is, we don't know what our opposite is. We know that hold on one second. Sine is opposite over hypotenuse, O over H. All right, so we know that our opposite is unknown, but our hypotenuse is 4. So, ladies and gentlemen, we have to take a detour here. This is another scenario where you have a problem within a problem. So the intermediate problem here involves us finding out what the opposite is. And then we can find out what sine theta is. Alrighty? Okay, so how do we find the opposite? We are going to call on our formula for finding a missing side of a right triangle, the Pythagorean theorem. A squared plus b squared equals c squared. Or in the context of this problem, opposite square plus adjacent square equals hypotenuse square. This is a trig version of the Pythagorean theorem. They're the same thing, okay? All right, so our opposite, we don't know what that is. Let's just call it opposite square, plus our adjacent is -3 square equals our hypotenuse square 4 square. So we're going to solve this resulting equation for opposite, okay? Let's do it. So we just expand everything. So opposite square, -3 squared is 9, plus 9 is equal to 16. We subtract 9 from both sides of the equation. And then we have opposite square is equal to 7. To get opposite isolated, we take the square root, which is the inverse of square. And then our opposite is either going to be plus or minus root 7. Okay, so the location of the opposite will tell us what the sign is. Now, if you look at the opposite sign, is going in the downward direction, the negative y direction. So in Q3, guess what? The opposite is always going to be negative. So it's going to be negative root 7. That's the option we're going to select. Okay, so we now know what the opposite is. So sine theta is going to be negative root 7. Using so, negative root 7 is the opposite over the hypotenuse, which is 4, ladies and gentlemen. That is the answer to question number 5. So our answer, let's see what the answer is option number 1. Okay, so that's method 1, using a right triangle trig. Now there's another method that we can use to solve the same problem. Method 2 is slightly more sophisticated, and it just requires you knowing your trig identities and the signs of the 6 trig functions in the respective quadrants. Method 2 is going to be the use of the trig identities. All right, let's take a look at this one. All right, so method 2, trig identities, we need to know the exact trig identity that we need for this particular problem. There are a lot of them, okay? So let's pull it up. The one that we need for this problem is known as the Pythagorean identity. There are 3 of them, 3 Pythagorean identities, but we need the one that relates sine and cosine exclusively. And the one that relates sine and cosine only are sine square theta plus cosine square theta is equal to 1. And then you also have to remember the sign of your 6 trig functions. Awesome. Students take calculus. So basically in quadrant 1, everything is positive. In quadrant 2, sine and cosecant are positive. Quadrant 3, tan and cotangent are positive. In quadrant 4, cosine and secant are positive. Everything else is negative. All right, so our focus in this particular problem is in quadrant 3. Only tan and cotangent are positive. Since we're looking for sine, we know that it's going to be negative. All right, so let's go ahead and do this. So to solve this problem, we know what cosine is, right? So we just substitute it into the Pythagorean identity. We have sine squared theta plus cosine squared theta. Cosine squared theta is negative 3 over 4. All right, square that equals 1. So we'll solve this trig equation for sine theta. Determine the appropriate sign using Awesome Students Take Calculus, and we are good to go. All right, so let's simplify this. We have sine squared theta. If you square negative 3 over 4, if you square negative, it becomes positive. The numerator becomes 9, and the denominator becomes 16 equals 1. All right. Now to get sine squared theta isolated, we're going to subtract 9 over 16 from both sides of the equation. Write this as a fraction. We need to find the LCD, so we just multiply this by 16, top and bottom. What does that yield? We have sine squared theta equals 16 over 16 minus 9 over 16. Since the denominators are the same, we can now proceed to subtract the fractions. So we have sine square theta is equal to 16 minus 9 is 7 over 16. All right, and then to get rid of this square component, what we're going to do is take the square root of both sides. All right, so square root that, square root the numerator and the denominator. So since you're taking the square root of a square, you're going to have sine theta equals plus or minus root 7 over 4. Alrighty. Now, what sign is this going to be? So from Awesome Students Take Calculus, we know that in quadrant 3, sine is negative. Only tan and cotangent are positive in quadrant 3. Okay? So in quadrant 3, in Q3, sine is negative. So what does that tell us? It tells us that our final answer, sine theta, is equal to negative root 7 over 4. As we already have, that is option number 1 as the answer to question number 5. Ladies and gentlemen, which method do you prefer and why? Do you prefer the right triangle trig method or the method of trigonometric identities? Tell us which method you prefer in the comment section below, and also indicate to us as to why you prefer that method. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is extremely valuable to us. Do not forget to subscribe to our channel. We upload math videos to our site on a weekly basis. And to get access to tons of support resources to help you pass the Regents exam, do give us a visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.